Personally, I hated the ending of the Game of Thrones. What if I could create a new season in which there's a different outcome? You want to create more episodes of Family Guy. You want to create more episodes of South Park. You can create more episodes of Simpsons. Different ending for Spider-Man. And of course, a different ending for Thanos. Now in all these examples, one thing is common. We were not happy with the ending and we want more variety in the contents that is being produced. Fear not, because we have a revolutionary multi-agent simulations known as Show 1 and Showrunner. Now we have had a taste of these agents in this paper called Generative Agents, in which 25 agents were simulated in this little environment, and each have their own thoughts. Each of these agents can plan their days, share news, form relations, and coordinate group activities. This is one of the paper which was the finest of its kind. But now we have another paper, To Infinity and Beyond, which is a Showrunner agent and a Show 1, what they call. It is used for multi-agent simulations. They have tested this out on the episodes on the TV show known as South Park. And in this work, they present their approach to generate high-quality episodic content. So it will be a full 22-minute long content for the intellectual properties using large language models, custom state-of-the-art diffusion models, and their multi-agent simulation for contextualization, story progression, and behavior control. Powerful LLMs such as GPT-4 were trained on a large corpus of TV show data, which lets us believe that with the right guidance, users will be able to rewrite entire seasons. That is pretty good. Now, sure, as much as exciting and good the current generative AI systems are, the current AI generative systems, Stable Diffusion, which we use for the image generator, and ChatGPT for the large language models, they are very good at, excuse me, my dog is barking, they're very good at, and they excel in the short-term general task through prompt engineering. But for a more longer duration task, for a more sustained and thoughtful task, these models, Stable Diffusion or ChatGPT, doesn't provide a very good solution. Now we need to get around that somehow. So this is an example of a example still from the South Park AI episode. Now the simulation has to be sufficiently complex because it involves different items, the voiceovers, the plot, background, characters, and everything. And it has to be non-deterministic to favor a positive disconfirmation. We don't want the same type of episode, but we want some mix in the episode. Now the large language models can call for several challenges such as hallucinations and unexpectedness, but we need a way to get around that. Now this issue of slot machine effect. The slot machine effect refers to the scenario where the generation of AI produced content feels more like a random game of chance rather than a deliberate creative process. Okay, so we need to get ahead and remove this issue of slot machine effect, which they have done thoroughly in this paper. Now this is an example of the user interface that we'll get. From left to right, we have Stable Diffusion Gradio here, we have the ChatGPT interface here, and then we have the Runway Generation 2 here to generate the videos. Moving on, of course, they have used the GPT-4. Now GPT-4 is a transformer architecture. This is all familiar. We have the encoder only and the decoder encoder here, architecture here for the transformer model that is known to you. The combination of vector embeddings and transformer-based architecture in LLMs facilitates a deep and a nuanced understanding of language, which is why these models can generate such high-quality human-like text. Now this is an important point. Fast thinking pertains to instinctive, automatic, and often heuristic-based decision-making, and that is where GPT-4 and Stable Diffusion excels, whereas slow thinking involves deliberate, analytical, and effortful purposes, which is where we as humans know and progress because of this. And we want to inculcate this quality of slow thinking. You might have read a book of slow thinking, slow and fast thinking, or something like that. So that was a book which shows that this principle. Now, we as humans, we are slow thinkers. Almost all of the humans are slow thinkers, and this is where we can achieve great results, analytical results. Now, while these models have made remarkable strides in text generations, their fast-thinking nature may limit their potential in tasks requiring deep comprehension and flexible reasoning. Let's move on. Now, we know embeddings. This is what embeddings are. This is the text is converted to vectors used by the computers, and similar semantic vectors will have almost the nearest values. So this is how the embedding model creates embeddings from text. Now, if we think slow, then we can dramatically improve the ability to reason in different contexts, such as solving math problems. That is an important thing of slow thinking. Now, when we think slow and in a discontinuous task, we will be able to solve math problems that requires a novel or creative application of a formula. We can write a joke or a riddle, coming up with scientific hypothesis and a philosophical argument. So all these require slow thinking and discontinuous task. Okay. So the GPT-4 for the agents in a simulation, as well as generating the scenes for the South Park episodes. Transcription is available and that has been used as a training for the GPT-4's training data. And GPT-4 has a good understanding of the character's personality, talking styles, as well as overall humor of the show. Let's move on to the diffusion model. The diffusion models operate on the principle of gradually adding and removing random noise from the data. So it has a comprehensive data set of about 1200 characters and 600 background images from the TV show. These models use Dreambooth, and there is two specialized diffusion models. The first model is dedicated to generating single characters set against a keyable background color. So that's the character here. The second model is trained to generate clean backgrounds with a particular focus on both exterior and interior models. So this is the background or the SVG image that is constructed using this prompt. Can you give me an SGV drawing of a house on a street? So GPT-4 generated this image. And this is how the stable diffusion model works. A resident building of South Park. So initially it starts with random noise, and ultimately it removes the random noise, and ultimately in 5 steps it is able to get a very clean picture of a house, a resident building in the South Park. Let's move on. And these are the images that has been generated by GPT-4 as VG images for automobiles, trucks, cats, dogs, like that. Now, simulations. Now, for the simulations, they use simulated data like relationships, personality, backstories, character description, and more to drive character behavior. And every character is provided with a reflection or reveries. For example, this is an example of a character reverie. I thought about taking my own life, but I realized I would never be able to do it. My roommate left for the day, and I took the responsibility to take out some of my anger on his stuff. I was in a bad mood, so I decided to trash the place. I ripped posters off the wall, tore up the bed, and emptied his bin over his desk. I was very angry. So what I wanted to show is there is hundreds of plot templates in the figure 10. If you see, this is an example of the plot template. So in the prior plot, after escaping the prison, our outlaw is searching for his former partner who betrayed him during his last heist. Current situation is that the outlaw learns that his former partner is now the leader of a powerful gang controlling the nearby town. The goal is to seek revenge. The obstacle is that we have tight security, and resolution is that forming alliance with disgruntled locals, the outlaw infiltrates the gangs and ultimately confronts the ex-partner in a duel. So this is a plot structure. Now, how do we generate episodes? Now, each episode has about 22 minutes of South Park episodes, and the authors have prompted the story system with a high-level idea, usually in the form of a synopsis and a major events that you want to see in each of the 14 scenes. So 14 scenes and 22 minutes of each episode. So here is the total showrunner system, what they are calling is a showrunner system diagram. Here the user first puts in the input here, and we have agents here. There is the actions that they can perform. There is a simulated data, and there is a creation of a prompt. So the prompt and input are fed to the large language models, GPT-4, and then there is the generation of a prompt chain and evaluation. And after the casting drop DR ops, a scene is generated and it is then cycled to get the best scene. After the scene is generated, the script is generated, the staging system is generated, spawn, camera system, voice generation, and then we have the playback. So each scene, at the end, what happens is that each scene simply defines the location, cast, and dialogue for each cast member. So this is exactly what we wanted. Now, how do we reduce the latency of the videos or audios? Now, generating a scene can take a significant amount of time, after 1 minute, but we want to avoid unwanted pauses between dialogue lines. So what they have implemented is a simple buffering system which generate at least one voice clip in advance. So when one character is delivering the voice clip, they already make the web request for the next voice clip in this fashion. So there's a zero delay voice clip generation here. Now the speed comparison, if you look at the number of tokens and the speed, so you can see that for about 500 number of tokens completion, the speed response time is less, the least for GPT-4. It is faster for GPT 3.5, even more faster for Azure GPT 3.5 Turbo. And creative thinking, so they want to emulate the creative thinking because we don't want the same type of episode. So in their experiments, they try to mimic a discontinuous creative thought process. Okay, so this continuous slow thinking process that would help in generating long sequence of scenes and long storytelling process. So they have explored new concepts known as plot patterns and dramatic operators, DR ops, to enhance the episode structure overall, but also the connective tissue between each scene. So this is an example prompt from AutoGPT. So we have the goals plus initial prompt. We retrieve the memory. This is the previous memory, and the next triggering step is made using the expert models and additional opinions as well. So it goes to the LLM thoughts, plans, reasons, criticize. So this is an AutoGPT format or setup. And then we get the response of the LLM. And if not, then we go to the next step, and this goes on iteratively. Now, there is this UI of the showrunner prompt. So this is the UI. I'm really excited to get my hands on the UI, which is still not accessible from my end. Now they have named this system or this process as show 1, and I am really excited to try everything. So let me read this conclusion and then we will end this video. So our approach of using multi-agent simulation and large language models such as GPT-4 for generating high-quality episodic content provides a novel and effective solution to many of the limitations of current AI systems in generative storytelling. By integrating the strength of the simulation, the user, and the AI models, we provide a richer and a more engaging storytelling experience that is aligned with the intellectual property story world. Our methods also mitigates issues such as the slot machine effect, the oatmeal problem, and the blank page problem that plagues conventional generative AI systems. As we continue to refine this approach, we are confident that we can further enhance the quality of the generated content, the user experience, and the creative potential of the generative AI systems in storytelling. Very grateful to Lewis Hackert for his help and expertise in training the custom stable diffusion models. Really excited to get my hands on this wonderful process, and if we can get the code, we can do the same process for other episodes. One of my favorite TV shows is the Family Guy, and we can create new seasons and new episodes for the Family Guy as well. I really wanted to change the ending of the Game of Thrones. Let's have season 9 for Game of Thrones. So that's an interesting proposition. I request you to have a look at this paper. Mention in the comment section which movie or which TV show you would like to change and make for yourself. So until then, next time, this is Prompt Engineer signing off, and I'll be back with interesting videos in the future. Bye bye.